Hello and welcome to the Daily Space for August 1st, 2018. I am today's host, Dr. Pamela Gay, and I am here to put science in your brains. CosmoQuest is the place that organizes this show. While you're giving us a listen, if you have a little bit of screen space left, if you have a few brain cells left, please consider clicking over to cosmoquest.org and doing some science while I'm here to help teach you some science. So, in today's top story, and in fact, in today's only story, I have Mars, and a little bit more Mars. As you may have heard, the near red planet has been completely encased in dust for about a month now. These two images show the Martian surface on May 28th and July 1st and bring home to us just how all-encompassing a Martian dust storm can be. Now, the timing of this particular dust storm is one that both makes it more awesome and also more frustrating. The reason for this dichotomy is Mars has been on its way to its closest approach to Earth. The two orbits of our planets cause us to, at some points, be on the opposite side of the sun from Mars, and at other points to be, well, snuggled up right next to Mars. And in some points in our orbits, our closest approach to Mars is also our farthest approach from the sun and Mars' closest approach to the sun, bringing us particularly close together. From our perspective here on Earth, we can actually see Mars appear to get larger and larger and larger in the sky as our two worlds get closer together. In this image here, you can see how from the period of February to end of July out to the end of February again, Mars changes in physical size. Changes in apparent size in our sky. Now, in this set of images, I'm simply showing you one particular snapshot that has been scaled up and down with time to show you how Mars' apparent diameter changes. To take a look at this in another way, this graphic shows where in their orbits Earth and Mars are from year to year as we have these closest approaches, and how from year to year the angular size of Mars in the sky appears to change. Now, the scientific term for this lineup of Sun, Earth, Mars is opposition. It means that Mars is opposite from the Sun in the Earth's sky. And in these different diagrams, you can see shown in blue let me show you on the correct screen. Shown in blue, you can see our planet Earth. Shown in orange, which may appear white, you can see Mars. And in these two particularly large images of Mars that you see, we have the 2003 closest approach of Earth to Mars that is going to probably be the closest approach in any of our lifetimes. And the reason I say probably is I'm leaving room for medical miracles. But without that occurring, we're not going to see an approach as close as we had in 2003. But this year was pretty darn close. So here we have the 2018 opposition. All the other circles that you see represent other years. Now, here we have Earth at its furthest point from the sun and Mars at its closest point to the sun. Here we have Earth closest to the sun, Mars farthest from the sun. And it's this difference in how our orbits are laid out that leads to this difference in angular size in the sky. Now, our closest approach is basically right now. The actual closest approach occurred last night. I probably should have brought you this story yesterday, but we had some pretty awesome science going on. So instead, I'm bringing it to you today because you can still get outside and look up. Now, this year, Mars at its opposition is also experiencing something that we only see in general every 5.5 Earth years. And this is a global dust storm. This amazing image that I'm showing here was captured at the beginning of June from, I believe it was Mars Express. Here you can see the dust storm sweeping across the Martian surface. Now, as this storm has grown in size, it has slowly encompassed the entire red planet. On the left, we have a series of images taken in May before the dust storm took over. On the right, we have a series of images taken in July showing just how little of the red planet's surface we can currently see. Now, this dust storm is allowing two different things to happen. On one hand, Mars is way brighter than it would normally be because all of this dust suspended in the Martian atmosphere is much more reflective than the normal, craggy surface that is covered in a variety of different surface features. This means that in addition to being larger on the sky than it would normally be, Mars is also brighter in the sky than it would usually be, even at this size. Now, unfortunately, this dust storm also means that we can't get those fabulous images of Mars surface features that amateur astronomers really look forward to being able to take during the oppositions. Now, while we can't image the surface features the way we might wish, this storm, this opposition, and all of the spacecraft we currently have at Mars are working together to allow us to study this dust storm in a way that we don't normally get to study dust storms. With our suite of various missions, we are studying the composition of the dust and how it changes over time with some of our low-flying spacecraft that are able to actually sample the upper layers of Mars' atmosphere. We have Mars Curiosity down on the surface, which is sending back image after image of, what it's able to see thanks to its nuclear power and the fact that it's not entirely dark where it's located. In fact, Mars Curiosity is continuing its science objectives. We had word coming from the spacecraft just yesterday that it is currently in an area of Gale Crater that is filled with very hard to drill into rocks. To try and find things that are easier to drill into, Mars Curiosity is currently, it's on the go, looking for some softer rocks to sample in the coming days. Now, while Mars Curiosity and its nuclear power is able to continue sending us back surface science from the red planet's surface, Mars Opportunity is not so lucky. Mars Opportunity is, in fact, dealing with circumstances that it hasn't really seen since 2007. This is, in fact, a selfie that Mars Opportunity took back in 2007, looking down at its solar panels. The 2007 storm only lasted a few weeks and was not that serious of a storm, and after powering down for a few weeks, both Spirit and Opportunity, our two Mars exploration rovers, were able to return to their science mission. This year, it's a game of wait and see. Opportunity is currently shut down into safe mode and is pulling itself back up every once in a while to basically check, am I getting enough sunlight to wake up and phone home? At this point, those circumstances have not actually appeared, and Opportunity continues to sit there Well, waiting for a little bit of sunshine. In safe mode, Mars Opportunity should be able to outlast the storm. But the word should is used because this was a spacecraft that was only slated to last 90 Earth days and has instead been going on for more than a decade. That's a long time for a little rover to last, and while we are all hopeful, we have to acknowledge we don't know how long this storm will last, and we don't know how long Opportunity's batteries can last and how long the spacecraft can continue before it's been shut down for so long that it just can't quite wake back up. Now, in the past, storms like the one that we're seeing right now have lasted as long as 4 to 5 months. Unfortunately, we don't have a whole lot of information on this kind of storm. We are having this amazing opportunity to learn about this storm. But since observations first began to be able to see these storms in fine detail back in 1925, we've only observed 9 world-encompassing storms. With only 9 of these world-encompassing storms that have been observed in the kind of detail that allows us to even know how long they might last, that's not a lot of statistically significant data. And as we know from storms here on Earth, one storm is not like another, and a sample of 9 is not enough to tell us, well, just how bad the rare worst storms can get. So this is one of those times where all of us in the science community are torn in multiple different directions. We have this fabulous suite of spacecraft and rovers at Mars right now, and we're uniquely positioned to be able to study the storm from a variety of different perspectives. So if this is one of those uniquely horrible storms, one that lasts months and months, we can see it in ways we've never been able to see one before. Mars is as close as it's going to get for years, decades. Mars has spacecraft it may not have on hand the next time one of these storms occurs. This is the perfect time for Mars to have a perfect storm. But at the same time, I know many of us have a sweet spot in our heart for the little rover that could and hopefully can again. And we don't want this storm to be the thing that kills Mars Opportunity. So, whatever the fate of the rover may be, however long this storm may last, we will be here at the Daily Space to bring you regular updates. For now, get outside, look up, look at Mars. It is a bright red gem in the sky that offers you no detail to observe through a telescope. But it's close, it's big, it's beautiful, and you can be the smartest one on the block by saying, "Hey neighbor, come out. That bright spot in the sky, that's a planet. Let me tell you a little bit about it." And hopefully this storm will provide amazing detail to all the science missions, to all the scientists here on Earth pointing our ground-based telescopes. And it will end quickly, allowing Opportunity to return to its continuing mission of science. Now, that's all the science I have to share here today on the Daily Space. As always, the Daily Space is brought to you by CosmoQuest. Visit cosmoquest.org and be part of exploring our solar system. Check out all the worlds that you can view, including Mars. We have a particular call for data from our Mars and Mercury science teams, and I would encourage you to check out these two very, very different red worlds of our solar system. They're actually both currently visible in the sky. Mars is far more visible than Mercury. So get out, look up, go online and look at these missions through cosmoquest.org, where you can contribute to the discoveries. CosmoQuest is a multi-institutional collaboration led out of the Astronomical Society of the Pacific. Following this show, you can tune in as Dr. Matt from the Planetary Science Institute brings you Astro 101 with his, student in location, our own ASP's Joe Myers. In addition to our Astro 101, we also have Astro Office Hours. The next office hours will be on Sunday with the Youngstown State University graphical artist and scientist Annie Wilson. Now, thank you so much for the bits, One Silent Storming. Our shows are all made possible thanks to you. Please feel free to give us a subscription and sustain our efforts, and every bit really counts. If you want to keep up with everything we're producing, give us a follow. Follows are free. Tomorrow evening, I will be bringing you Learning Space. Learning Space is your chance to, learn how it is that you can better get engaged in science through a variety of amazing programs that are offered both in the real world and here on the internet. So tomorrow's episode will start at 9 p.m. Eastern, 8 p.m. Central, that is 6 p.m. Pacific, and 11 a.m. Friday if you happen to be in Sydney, Australia, or that particular time zone. So thank you all, and I'm now here to try and answer your questions. Please go ahead, and as many of you are already doing, at me so I can better find your questions. So I see that Hanny is saying, if Mars is cooling, wouldn't we expect some geologic features on the surface from settling? I don't quite know what you mean by settling, Hanny. Can you ask that with some more words, please? And Mars, like all worlds, is very gradually cooling, but this is a super slow process that isn't quite what we'd really expect to see a lot of features from right now. Larry, I have to admit, I haven't had a chance to look over the article on black holes and fully understand it yet. That is one that is going to cause me to do a bit of research. Looking to see what else we have. So Hanny, the cliffs and features like that we currently see on Mars, those are often tied to craters. So when we have a asteroid impact, that is going to create a new feature that can take, millions to billions of years to show any change due to geologic weathering on the surface. Just like on the moon, we do see features slowly changing over time, and these changes are caused on the moon strictly by the world periodically getting shaken, not stirred, through the impact of other asteroids, which cause moonquakes, and also through slow destruction by a constant rain of small micrometeorites. On Mars, we add to those effects dust storms, which can fill in features, and basically erosion that can be caused by dust. So dust is both cutting away at features and filling them in, depending on what kinds of features it is that we're looking at. Now, with Mars, we do know that there are features that have been formed through geologic processes such as the massive volcanoes, Valles Marineris, which some believe may be caused by all of the lava that came out from under the surface through the various volcanoes may have essentially emptied out a cavity that led to a collapse and cracking. There's a variety of different features or different theories that are used to explain this particular valley. But whatever the particular reason is, Mars has been geologically active. Exactly how recently it's been geologically active, we're still trying to figure this out. And you can help us figure it out by helping us map craters over at Mars Mappers on CosmoQuest.org. There are some papers that say that it was within the past couple million years, and a few more extreme papers that say within the past few 100,000 years that Mars was geologically active. With things happening that recently, there just hasn't been time to see wear and tear on the world. Now, the kinds of things that you're talking about, we do see on Mercury. Mercury is noticeably contracting over time, and the surface is cracking as the world cools. We also see the surface getting weathered by cosmic rays, solar winds, interactions with the sun. And if you look at Mercury in some of the SDO data, you can actually see a tail of particles streaming off of Mercury, driven by this interaction with the sun. So lots of different things going on. So one silent storming, we see Mars quakes still occurring on Mars, but they appear to be driven more by impact events that shake the world rather than internal events shaking the world. We don't understand 100% that this is what's going on, and the InSight mission, which will be landing in November and carries a seismometer with it, will be helping us understand exactly what drives modern day Mars quakes. As far as we know, the only worlds with active volcanism, not ice volcanoes, but actual magma emerging through the surface, lava emerging through the surface. The only worlds with that kind of active volcanism today are Earth and the moon Io that is orbiting Jupiter. So it looks like volcanism may be mostly dead. Venus is a question mark. It is a different kind of world that appears to have punctuated volcanic activity, and it's unknown if the world is completely dormant. So Hanny Zworverp is commenting that the dust storms on Mars are roughly every 5.5 Earth years. This is somewhat cyclic, but it's one of these things where it does occur at a regular point in the Mars year, but it doesn't occur every year. So we're looking at punctuated episodes that on average are every couple of years, but aren't every couple of years. So Paranor is saying, doesn't Neptune's moon Triton have possible volcanic geyser activity as well? Yes, but that's cryovolcanism, not magma volcanism. So I'm trying to differentiate between the two here. So Hanny, to go back to your question, one way to look at it is here on Earth, some hurricane seasons are significantly worse than other hurricane seasons due to the heating of the oceans, and whether it's La Nina or El Nino in the Pacific Ocean being tied to typhoons, depending on the weather cycle that's been going on in northern Africa for our Atlantic hurricane season. And just as each hurricane season varies, each dust storm season varies on Mars. Do we have any other questions? Yes, DPI 209 Triton is similar to Europa and Enceladus, and perhaps even Ganymede may have subsurface oceans. We see that Ceres has cryovolcanism. We're finding cryovolcanism in a whole variety of different places throughout our solar system, and we still don't know the limits of where it occurs. And this is one of the crazy, awesome discoveries of recent planetary science. So stay tuned as we continue to look for more and more places with subsurface oceans, subsurface lakes, and the potential for cryovolcanism to take place. Do we have any other questions in the chat? So as I said, directly following this episode of Daily Space, I will be handing this channel over to Dr. Matt and his computer science student, Joe Myers. Joe is one of our programmers here at CosmoQuest, and while he knows his software, he's still learning his science. Dr. Matt is working to bring him up to speed and is inviting you along for the process. Dr. Matt is one of our planetary scientists who is helping us on the research we do here at CosmoQuest. So I see all of your king of discussions. I'd say that Io, in terms of worlds with the most volcanoes, is definitely the winner, while Olympus Mons does hold the title of largest individual volcano or mountain in our solar system. So lots of different things going on and lots of different ways to say biggest, baddest, best of all. So that appears to be the end of our questions. So I'm going to say thank you for tuning in, and come back tomorrow as we work to put more science in your brain. Once again at 1 p.m. Eastern, 10 p.m. Pacific, 6 p.m. London time here on CosmoQuest X on Twitch. Thank you for coming. Thank you for your support. And thank you for your follows. Your follows will help you keep up with everything that we're doing, and every subscription really helps to sustain our efforts, and every bit, well, keeps us going one day longer. So thank you, and I hope to see all of you tomorrow as I return with the science. Now, to help put understanding of that science in your brain, stay tuned as Dr. Matt and Big J start up this stream once again, coming to you from new locations with a new topic. This has been the Daily Space. Remember, wherever you are in the world, have a fabulous morning, evening, or afternoon, and get outside and look up, and especially take a look at Mars as it is close to the Earth and shiny in the sky. Bye-bye, everyone.